Yay, and let's do question 4, which is all about vectors, which we love. We love vectors so much. We've got our position vectors, OA and OB, and we find the unit vector for AB. So let's first of all find the vector AB. So remind ourselves how this whole dealio works. If I've got the vector OA, I've got the vector OB, then the vector AB, between there and there, I'm going to get that by saying that if OA plus AB equals OB, then AB equals the vector OB minus the vector OA. No, sorry. So in this case here, the vector AB is going to be 4i minus I, which is 3i. And in this case here, P is 6, so that's 6k minus no k, so that's just 6k. And then it's no j minus 2j, so minus 2j. If you want to make that, I guess, a bit more clearer, we could draw out OB like this. So OB is 4, 0, and then, because there's 0j component, and then 6 for k, and we could say the vector OA, if we write it out in column notation, is 1, 2, and then 0. So then you can see that when I subtract that, 4 minus 1 is 3, 0 minus 2 is negative 2j, and 6 minus 0 is 6k. Sorry, had a bit of a pause there for a second because I realised I've written these in not alphabetical order. So it should be 3i minus 2j plus 6k. Let's just tie that up now. 3i minus 2j plus 6k. So that's our vector AB. Cool. So that's the first part. The unit vector, all you have to do for unit vectors is you have to work out the magnitude of the vector and then just divide the vector through by that. So let's work out the magnitude of AB, and that's the same, remember, as taking each of the components and squaring them and then adding them up. Okay, so I've got my 3, my minus 2, and my 6 all there. And so I'll go along and square them and then add them up. So 9 plus 4 plus 36, which equals 49. So the root of 49 is 7. So I always start off by doing this root side here, just in case that's not a nice number, and I'll leave it as a third. But in this case here, the root of 49 is 7, so that's fine. So then my unit vector is going to be 1/7, because remember, timesing by a 7th is the same as dividing through by 7. So it's going to be 1/7 of 3i minus 2j plus 6k. My pluses are not very good today. There we go. So the main thing there is to remember that the unit vector, you work out the magnitude of the vector and then you divide through by that. And hopefully you guys are okay now with working out other vectors using position vectors. Okay, and on to part 2. So find the values of P for which this angle equals 1/5. Oh, that's alright. So we already have OA and we already have OB. So in this case here, the angle AOB, and we already have the vectors that we need, and we already have vectors that both originate from O. So they both go from O out to A or O out to B. So we don't need to manipulate our vectors at all first, which is awesome. We just have to find, we have to set up the equation for the angle between the two vectors, but leave P in there. So if we remind ourselves how that works, if we rearrange our formula, we're going to get the cosine of the angle is the same as the dot product divided by the product of the magnitudes. So let's do the dot product then. It probably is actually easier to write those babies out in column notation. So for OA, I component is 1, the j component is 2 and the k component is 0. And for OB, the I component is 4, the j component is 0, and the k component is p, like that. When we do our dot product, we're going to take each of those components that are the same and multiply them. So 1 times 4 plus 2 times 0 plus 0 times p. So we're going to end up with 4, just 4. That's easy. So that's the dot product there, is just 4. And then let's do the magnitudes. So if we look at the magnitude of this one here, so the magnitude of OA is going to be the square root of 1 squared plus 2 squared. So that's the root of 5. Of course, I should have used brackets around those just to be careful. And if we do the magnitude of OB, that's the same as the root of 4 squared plus p squared. So that's the root of 16 plus p squared. And before you get too excited and think, oh, 16, that's a square number, and p squared is a square number. No, you are not allowed to square root 16. Oopsie daisy. You're not allowed to square root 16 and square root p squared because these are joined by an addition sign. So we can't do any of that simplifying stuff unless things are joined by multiplication. Okay, so we have to leave it how it is. So it's the root of 16 plus p squared. Okay, so let's form this together. We know that up here that all of this is supposed to equal a fifth, and then we would inverse cosine it to find the angle. Okay, so all of this equals a fifth. So we can set up an equation. So if I actually add a fifth there, let's piece this all together to make an equation. So we know that, first of all, a times b is 4. Okay, and we now know that for the bottom, the magnitude of a is, where's that gone? It's the root of 5, and the magnitude of b is the root of 16 plus p squared. So let's put that all on the bottom. Root of 5 and root of 16 plus p squared. And that all is going to equal 1/5. Stop that for a second. Now that does kind of look a little bit scary, but fractions are our friends, and our new little mantra also is that surds are our friends. Because surds, they just want to be squared. You know, they just want to be loved, they just want to be squared. That's all we have to do to deal with those. So let's do a little bit of cross multiplying across here and across here. So we're going to get 20 equals the root of 5 times the root of 16 plus p squared. Okay, and now what we can do is we can square both sides, and that will help us get rid of this surd sign. So if we square both sides, we're going to get 400, and that's going to equal 5 times 16 plus p squared, which is pretty exciting because at this stage we should be able to say we've got a quadratic about to emerge, which is awesome. If we divide both sides by 5, we're going to get 80 equals 16 plus p squared, and if we take 16 away, we're going to get p squared equals 64. And then that means that p equals plus or minus 8. So I've taken the plus or minus square root of 64. So I've got two solutions, either 8 or negative 8. And we're done.